Right, in this video, we are looking at transformation of functions. And by the end, I want you to be able to describe, recognize, apply four types of transformations. And so what I mean by transformations is a way to adjust or massage or move any of the functions that we have. These ones here are just a few, 8 of some base functions that we know, but there's tons more different types of functions that you can move. So for example, this linear function, and I guess that one there's not a base one. The base one would be y is equal to x, and that line would go something like this. I guess this is a good example. So if that's the baseline, the blue one, so what did I have to do to the base function, other than just add a 3 and a 2, to get this red line? I guess I can make it red. To get this red line here. So what did I have to do? What transformations happened? And that's what we do when we're modeling any kind of function. Currently, we're in a coronavirus pandemic, and they're talking about models and the number of deaths, the number of cases, and when we can go back to normal life, if we could ever do that. And they talk about modeling, and this is what this is all that they're talking about. Initially, the pandemic looked a whole lot like an exponential function like this one, but now it has changed a little bit. So if I can assign, or if I can relate a situation in real life to a basic function, and I can determine how the basic function has transformed a little bit, then I can maybe extrapolate, or I can figure out what might happen in that particular problem. So these are all the base ones, and all of them we can transform with lots of different ways, but we're going to talk about 4 different transformations that you can do to all of these functions. And the same principle applies to every one of them. And the same, those 4 things do the same thing to each one of the functions. So the 4 different things, we've labeled them with letters, and some books use different letters. I think ours use A, B, C, and D. So if I put a number out front of a function, it does something. If I put a number, and when we're looking at any of these, my title up here is important, see what's happening to the x. So there's a number out front of the x here, like way out front. That does something to the function. This number that's inside brackets and right in front of the x does something. This letter C that is still in brackets, but it's being added or subtracted to x, does something. And this D at the end also does something. So I'm adding or subtracting something at the end. It does something, transforms the graph somehow. And it's important to be able to label which number is an A, B, C, or D. So take a look at these ones that I've got. I've got them mixed up. This is a matching game. See if you can match up just on your paper. Just press pause after I'm done talking here. And see if you can match which of the things on the right are associated with the thing on the left. Okay, pause, try it. Okay, we're back. So when you take a look at this first one, the 3 is out front of the function, and so I would call that an A. So that's an A transformation. Okay, this one here, it's a number being added or subtracted to the x, and it's not in brackets, so I'm calling that a D. Okay, this one here, there's a number inside the brackets that's being added or subtracted. Notice it's different than the D one, because this is in brackets, it's being added or subtracted. I'd call that a C one. And then lastly, this one, it sort of looks funny because it's up as an exponent, but this is the base part of the function, and there's a number being multiplied by x. So it is a B value. Okay, so we need to explore what all those A, B, C's, and D's are. We can recognize them now. Let's explore what happens. And to do that, what I'd like you to do is fire up your desmos. And I'd like you to type in either that, or you can type them in both if you want. So I'm going to, well, you can pause and I'll pause too, and I'll input those. But I want you to input them, and there'll be a spot that says add variables or something, and you want to hit all. Okay, I'm going to pause, type it in, see how you do. It might take you a few tries. Same with me. I'm pausing too. Oh, to get those letters, the A, B, C, and D, you'll notice at the bottom left there's an ABC button. You can hit that. That'll get you your ABCs. Okay, hopefully you've put those in and you've hit that add a slider button. Okay, so what I want to do is I want to play with what A does, what B does, and what C does. Usually A by default is 1. So make sure that A, the slider says 1. And then by default B is also 1. That's good. By default C should be 0. So maybe change that to 0 if you can. I think you can actually type, type 0 in if you want, if you can. 0 there. And D, make D 0 as well. Okay, so there is a normal quadratic function with everything, all the values at default. So I want to play with A. So I'm going to move it to the right and just see what happens to the problem. Okay, so as I move it to the right there, notice it's getting skinnier and skinnier. And as you move it wider, it gets fatter and fatter. Now, what's actually happening there is the y values are being multiplied by whatever a is. So if you fix on a y value right there, what would be a good one? Right there at 2 and 4. I don't know if I can do this or not, but at 2 and 4, right there, there's a point. So if I change my y value, let me see if I can go back to do that. If I change my y value, oh yeah, it lets me. See how what happens is that y value, instead of where it's at, the y value, depending on what my a is, it multiplies and gets bigger. So what's happening with A, and if you want to write down some notes, A is a vertical stretch. Multiplies y values by whatever A is. Now, we can get it really skinny, but we can also make it go wider. Whoa, go wider and wider. And notice that you can get it so it actually almost goes flat, or does go flat. And then also what happens is it flips over. So A, vertical stretch, by whatever a is, so you multiply all the y values by whatever a is. But also, notice when it flipped what the value of a was. It turns out to be negative. So a will also reflect the graph on the x-axis. So it just flips it over. So that's what a does, okay? And feel free to move that around however you want. I sort of get a kick out of moving that around. Okay, so let's move a back to 1, or close to 1. There, 1. Now let's take a look at B. And B does something similar, you'll find. But B is, it's doing a different stretching. And when you look at it, it's hard to see that, but it is doing a different one. Okay, so let's take B and let's make it bigger. That almost looks like the same thing that is happening that happened with the A value, which is sort of funny. Same thing. But what B is doing is rather than multiplying the y values by whatever that number is, it's taking the x values and dividing them. So B you can call a horizontal, stretch, or squish. So there it's stretching it, here it's squishing it. So you can call it a horizontal, stretch, or squish. And to determine what happens to the values, you just divide whatever x value you had by whatever b value you had. Okay, so that's B, horizontal, stretch, or squish. Oh, we didn't do a negative thing. Now, with this one, it'll be tough to see what happens when you go negative because it really won't change much. Watch. So all it did is it didn't, like A flips it over the x-axis, but this one, it seems like there's a change there. But what's happening is if B is negative, what it's doing is it's flipping it over the y-axis. Now to see that that's happening, let's just move C and then let's go back to B and see what happens. So take C and maybe move it over a little bit. Oh, that's interesting. We'll get to that in a second. Okay, let's go back to B. So now watch what happens there as I move B one way or the other way. Wham. See how that it flipped? So right now, if B is positive, it's on the right-hand side of the y-axis. When I move it negative, it flips it to the other side. So B, its job, I guess, is a horizontal stretch or squish, and it also reflects over the y-axis. Let's put B back at 1. B's back at 1 there. Oh, close enough. Okay, so let's see what C does. So if you take a look at C, C at 0 will be right in the middle. If I make C positive, it moves to the right. If I make C negative, it moves to the left. Did I say left? Negative left, positive right. We'll see that in the actual formula, though, the formula has a minus there. So in interpreting that, sometimes you have to switch that in your mind. Anyway, C, left, right translation. So you can move things to the left or to the right. And then D, you probably figured out already, will move things up or move things down. Okay, so it's a vertical translation. C is a horizontal translation. B is a horizontal stretch or squish and flip over Y. And A is a vertical stretch or squish, and it's a flip over the x-axis. Okay, now we played with this graph. Let's see how that applies when we just looked at a formula. So here's, I guess, an equation. Y equals 3, 2, x plus 4, bracket. Okay, so what I need to do is identify what each of those numbers or do in terms of a transformation. So I always start with do the order of operations. And so order of operations says do stuff in brackets first, then any exponents if you have them, divide, multiply if you have them in that order, and add or subtract if you have them in that order. So brackets. So I've got big brackets here, and then I've got little brackets. So I should start in here. So the first transformation I'm going to look at is that one right there. And like it shows up above, that's a C value. So that's where I would start, is with the C. And then inside these larger brackets, I've got a value right there. That would be a B value. So I would probably do a C, then a B. And then outside of the brackets, this is being multiplied, so I do that one. And that's an A value. And then lastly, I would look at the D value, this one here. So C bad, if you want to remember that as the order, that it's a good idea to look at the transformations. So the C value is this one right there. It's a 4. And if you do the slider thing, it's the thing that moves things left or right. So this one, because this sign here is positive, it's different than this one. It will go opposite to what you think. So plus, you think, well, it should go right. But if it's plus, because it's opposite to this one, it goes left. So the C value tells me to go left 4 units. Then let's do the B value. The B value is 2. And so that's the horizontal squish. The bigger number, the squishier it becomes horizontally. And if you want to say it's horizontally squished by a factor of 2, that would be the appropriate way to say it. Okay, and then let's look at A. So A is the horizontal stretch. So this particular one, since the number's larger than 1, I'm going to have a horizontal stretch by a factor of 3. And then finally, the D value is this one, the D value, and it's normally what you would think. If it's minus 4, that means the graph gets moved down by 4. Okay, on the next slide, I'll give you a couple that you can test on. So take each one of these and see if you can determine what each one of those transformations will do to the graph. Press pause, try them, then come back, see if you're right. Okay, so I would start in the brackets here. So this one tells me it goes left 2. And then I do this one outside. This one would be the vertical stretch by a factor of 2. So you're multiplying all the y values by 2. And then the 3 at the end, this one would move things down by 3. Just while we're doing this too, notice that the stuff inside the brackets here, the b or right up here, the b and the c values, they affect the x coordinate. So they'll either multiply x by something or add or subtract x by something. So the things in the brackets affect x. And the things outside the brackets, those guys, they affect y values. Okay, let's look at the next one. Inside the brackets, this thing would get moved right by pi. This thing here would be horizontally stretched by a factor of 3. And this one, it would be flipped over the x-axis. And then it would be moved up 1. The next one, up here, this is sort of like it's in brackets. So I would move the graph right 2. And then this, the negative sign there, would reflect it over the x-axis. And finally, it would move down 3. Last one, this here would be the horizontal squish by a factor of 2. And then it would be moved right by pi. Okay, now let's take a look at going backwards. So I'm given some information. I have to write a graph or write a function from it. So they say I want the graph to be in this shape, but it has to get moved right 3 or right 6 and down 3. So my basic graph is y equals x squared. If I'm going to move things to the right 6, that's a c value right there. So it has to be in brackets. So I would probably transform this to look like y is equal, let's put brackets there. Inside here I'll have an x and a 6. Moving it right is just the normal, and so I have a minus there. And then if they want you to move that down 3 units, I'd take that one, and if it's moving down 3, I'd tack a 3 on at the end. Okay, let's try this one at the bottom, or you can try it. Press pause, see if you can do it. Horizontally compressed, that's a b value by a factor of 5. So I'm going to write y equals sine 5x. I can put that in brackets. Leaving it without brackets is okay too, but typically I like to put it in brackets. Then it says reflected across the x-axis. That's the y one right there. So I need to put a minus out front to make it flip across the x-axis. Okay, another thing I can do is I can give you a point and say this point is on a normal graph. So if you transform the graph, what is that going to do to this point? And what you want to do for this question and the next question on the next slide is to look at what affects x and what affects y. So this thing out front here, that's in an A spot. And so that only affects the y value. So here, my point is negative 4, 2. That's what it starts at. And so it's going to be transformed, but the only thing that's going to be transformed is the y value. So the x value is going to stay the same. And now all I have to do is take half of the 2. So multiply a half by 2, I come up with 1. This would be the corresponding point on the transformed graph. Okay, now let's take a look at transforming a whole function. And it's a function that we don't have an equation for. I guess this is all that we have, but there's nothing that really, I don't have a whole equation to talk about this. But I do have points. So I have points that are along that graph. And they're the points that are for that graph. But now what I want to do is I want to transform that graph. So I'm going to transform it by doing this and this and this. Again, what you want to think of is what do each of those things do to the x values and to the y values. So I always start with the x values. So maybe let me put a table up. Let's get this point. So let's start with this point here, minus 4, 0. So that's the initial one. That's on f of x, just f of x. And now if I do this to the graph, that's going to move the graph to the left 1. It's going to affect the x values. And so it's going to affect this value. And if I move that to the left 1, if it's at minus 4 now, if I move it to the left 1, that'll be minus 5, 0. Okay, and that is a C transformation. Remember our ABCD thing? That would be a C transformation. Okay, now I think that is the only thing that affects x's. So now let's go to the next one. That would be this one. That's A, because there's no B value here. I could put a B here, but there's nothing there. So let's go now to the A value. So A value, in order to get the A value, I need to multiply any Y value by this number and flip it over. Basically, all you have to do is multiply it by negative 2. So I'm going to take this Y value and multiply it by negative 2. So I leave the x alone. 0 times negative 2, is still 0. And then lastly, I'll do the D value. And the D value, this one here, moves things down 2. Again, it affects Y. So this is affecting Y. Over here, this was affecting Y as well. So the Y value has to go down by 2. If it's at 0, if it goes down by 2, it's going to wind up at negative 2. And I didn't do anything on that step to the x value, so it stays at that. So if I were doing the transformed graph, I would go to minus 5 and minus 2, and I'd put a dot. And that dot is the transformed version of that dot. Let's try another one. Let's try minus 3, minus 2. So minus 3, minus 2, let's do C. C tells, and maybe I should put it right in there. I'm going to say left 1. And then B does nothing. So nothing. And then A, I have to multiply everything by a negative 2. So I have to multiply the Y values by, I should put a Y in there. Multiply Y's by negative 2. And then the D value, I subtract 2, or I go down 2. Okay, so let's try it with this point. Minus 3 and minus 2. So the first one I have to move left 1. So to move this left 1, it would go to minus 4. And notice the Y value doesn't change. There's no B value, nothing happens there. And then in this one, there's nothing going to happen anymore to the X value. So that one stays and this one stays. There's just Y stuff that happens. So I have to multiply the Y value by a negative 2. So here's the Y value. Negative 2 times negative 2 is a positive 4. And then I have to move it down 2. So if I'm at 4 and I go down 2, I'll be at 2. So this point here, I can plot. So minus 4 and 2, right there. So that point is similar to that point. Let's try another one. Negative 1, negative 2. Hopefully you're getting on to the idea here. So first thing, I have to go left 1. If I'm at minus 1, if I go left 1, that'll be a minus 2. And of course the Y value stays. B, there's no transformations happening with that. Okay, and then from here on in, there's no transformation to the X value. So the minus 2 stays. But for Y, in this step, I have to multiply the Y value by a negative 2. So that'll be a positive 4. And then I have to move it down 2. So that'll be a 2. So minus 2 and 2, that'll be that point. Now if I join things, you can probably see what's going on. So it's similar to what's happening at the start of this graph. I'll do one more. You should do all of them, but I'll just do one more, just so you're getting the idea. Let's pick that point right there, 2 and 3. Okay, so I need to move left 1. So if I'm at 2 and I move left 1, I'll be at 1. y value stays the same. B, there's no B transformations. So the 1 is going to stay the same for the last transformations. Now, for this one, I need to multiply that by a negative 2. So 3 times negative 2 is a negative 6. And then I need to move it down 2, so that'll be negative 8. So the point 1 and negative 8, oh, that's way down there somewhere, will be my next point. And then all you do is you just join all the dots, and the graph that you have finished will be your transformed graph of this top one based on that pattern or that model right there. Okay, so in this section we've looked at 4 types of transformations. We labeled them actually A, B, C, and D. Maybe I'll put them with the function A, f of b, x minus c over b. And this fraction will come into play when we look at trig, but I just want to make sure we put it in there now, plus d. So A does vertical stretching or shrinking and also reflects it over the x-axis. B does horizontal stretch or squish, and it also reflects things over the y-axis. The C value, that thing moves it left or right depending on what the sign is, and the D value moves things up or down depending on what the sign is. Okay, try the video quiz, try some homework questions, and let me know if you have any questions.